Hi, we are going to do Formulae rapid revision in current electricity for +2 students. One point I want to make it very clear. Here we are not going to teach anything. Only a Formulae revision, rapid revision in current electricity for standard 12. Okay. Electric current. You know very well, current is the rate of flow of charge. So I can write I is equal to dq by dt. And you know very well Q is equal to Ne, where N is the number of electrons and E is the charge of an electron. E value 1.6 10 power minus 19 coulomb. Basic formula for electric current. Next, drift velocity. Drift velocity. V suffix d is equal to, velocity is nothing but acceleration is velocity by time. So velocity is nothing but acceleration into time. Both are vectors, so we are putting vector. And you know very well, acceleration is force by mass. Here we are using electric field force. Electric field force means what is the meaning, ma'am? Newton's second law. F is equal to ma. So A is equal to F by m. When it is subjected to external electric field, the force is EQ. Here, one electron we are taking. So E into E. Vector form I want to write means you have to put a negative sign. So acceleration into time. This time we call it as relaxation time. Relaxation time. This is another form. And the next is mobility we want to use here. Mobility. Drift velocity per unit electric field. Vd by E. So what is remaining? E by m into tau. E by m into tau. That is mobility. Drift velocity per unit electric field. Mobility formula. Correct? Next, current density. J. Current density is current by area. J is equal to I by A. Current by area, we call it as current density. And one more formula we have. J vector is equal to sigma into E. The sigma is called conductivity. We'll explain later what is called the conductivity. Electric field is a vector. Current density is a vector. Current is a scalar, but current density is a vector. Why, sir? Means area, normal of the area we are taking. Normal of the area means it might be in two directions. So we are representing current density as a vector. This is called a microscopic form of Ohm's law. Microscopic form of Ohm's law. What is macroscopic form, sir? V is equal to IR. To remember, I used to tell the students, remember, vegetarians are higher. Vegetarians are higher. Remember, remembrance. You cannot write in the exam and all, remembrance. R is called a resistance. This is macroscopic form of Ohm's law. Resistance R is directly proportional to the length and inversely proportional to the area. Resistance of the conductor directly proportional to length, inversely proportional to area, or R is equal to constant rho into L by A. This rho is called specific resistance or resistivity. Resistivity or specific resistance. So rho is equal to RA by L. Unit of resistance is ohms. So I can write ohm. Area is meter square. Length is meter. Cancel. I can write ohm meter is a unit of resistivity or specific resistance. Both are same. Resistivity, specific resistance, both are same. Next, conductivity. Conductivity. Sigma. That is 1 by rho. Inversely proportional to resistivity. So I can say 1 by rho. We call it as conductivity. What is rho? RA by L. So conductivity will be L by RA. Unit of sigma inverse. Ohm inverse, meter inverse. Sometimes we can write this as mho. Ohm inverse. When you go for higher classes, you will learn mho is a unit of conductance. Conductivity is sigma. Conductance is sometimes represented as G. That is G is equal to 1 by R. 1 by resistance is called conductance. Conductivity, sigma, 1 by rho. Simple concept, ma. Next, for various purpose, for electronic circuits, we will use resistance, inductance, capacitance and all. So every resistor is a small piece. Every resistor, when after manufacturing, we cannot take it and write it in number. 10 ohms, 100 ohms, 45 ohms, 1000 ohms, like that. So they have put a color combination for various resistors. Depending upon the color, you can find out the number. B.B. Roy, Great Britain, very good wife. You can remember like that. Black, brown, red, orange, yellow, green, blue, violet, gray, white. Actually, black and white is not a color at all. No color means black. All colors means white. B.B. Roy, Great Britain, very good wife. For remembrance, my teacher taught me around 35 years before. He told his professor taught. So it is a story going on for more than 50 to 60 years. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each color represents a number. Okay. So when you take a resistor, 3 colors will be given at one end. Other end, for tolerance capacity, tolerance of the resistor, silver color, gold color, brown, red, no color at all, like that and all it is given. That is tolerance. We are not talking about that. We are talking about resistance value. First color represents a number. Second color also represents a number. Third color represents number of zeros. What is the meaning, sir? I have orange, red, brown. 3 colors I am having. Orange, what number? 3. Red, what number? 2. Brown means 1. So 1 0 you have to put. So third color represents number of zeros. No, sir, I am having yellow here. What is yellow? 4. So 4 zeros you have to put. First 2 color represents number. Third color represents number of zeros. This is carbon resistors. Okay. Now resistors in series. The resultant resistance will be R1 plus R2 plus R3, etc. Resistors in parallel. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, etc. Resistors in series, resistors in parallel. Simple. Next, temperature coefficient of resistance. Temperature coefficient of resistivity alpha. Formula says delta rho. What is rho, ma? Resistivity or specific resistance. Delta rho means change in resistivity. We are not teaching here, we are only explaining. Delta naught into delta T. Resistivity, change in resistance by resistivity, change in resistivity. Change in resistivity at 0 degrees Celsius, change in temperature. Unit of this is ohm meter, unit of this is ohm meter, cancels. This is Kelvin, so unit will be Kelvin power minus 1. No, sir, temperature coefficient of resistance only I want. No problem. Delta R by R naught delta T. Same unit, because these two units get cancelled. Resistance at any temperature can be given by the formula RT is equal to R naught into 1 plus alpha into T minus T naught. T naught is the temperature 0 degrees Celsius. T, any given temperature. Alpha, temperature coefficient of resistivity. R naught, resistance, temperature coefficient of resistance or resistivity. R naught, resistance at 0 degrees Celsius. RT, resistance at any given temperature. Clear, ma? So this is next concept about temperature coefficient of resistance. Okay. Electric power and electric energy. The general formula for power, you know, rate of change of energy, du by dt. Energy or work done, charge into potential. First chapter we have studied. That is electrostatic chapter we have studied. So I can write d by dt of small t we will put. Because capital mean temperature will become. So this is time. What is energy? Potential into charge. Charge into potential. Take V outside, dq by dt. Rate of flow of charge is what, ma? Current. Just now we have studied. So V into I, we call it as power. Electric power. Mechanical power means work done by time. Electric power means product of voltage into current. Okay. Next, energy. Energy means you can write power is energy by time. Energy is power into time. That's what you are studying as Joule's law. H is equal to VIT. H is equal to, instead of V, we can put IR, I square RT. H is equal to, no sir, I want to write as V by R. V square by R into T. All are same. And all time question, 1 unit. That is 1 kilowatt hour. That is called 1 electrical unit. 1 kilowatt hour is equal to 3.6 into 10 power 6 joules, or 36 into 10 power 5. How it has come, sir? 1 kilo, 1000. 1 kilowatt means 1000 watt. 1 hour means 3600 second. Multiply 3.6 into 10 power 6. Okay, next. Internal resistance of a cell. Any cell has got an internal resistance. So the formula R is equal to psi minus V by V into capital R. The psi is called EMF of the cell. V is called the voltmeter reading. Across the cell, you are measuring the voltage, that voltmeter reading. R is the external resistance which is connected. Psi minus V by V into capital R. Suppose so many cells connected in series. Cells in series. Cells in parallel. So many cells connected in series. What is called the effective current or total current? Total EMF by total resistance. Current is always voltage or EMF by resistance. Total EMF by total resistance. What is total EMF? Psi is a single EMF, sir. So what is the total EMF here? N psi, simple. I told you already, psi is a EMF of the cell. So N psi is a total EMF. Every cell has got an internal resistance. So what will be in denominator? What will be in denominator? No? It is NR plus capital R. R is external resistance you are connecting. Every cell has got an internal resistance. So NR. Next, cells in parallel. I is equal to. Cells in parallel means same N psi R plus NR. Derivation, you can refer. Only the final formula we are writing. Cells connected in series, cells connected in parallel. All-time question, very, very important when you go to college also. Kirchhoff's first law, otherwise known as current law. Algebraic sum of the currents meeting at any junction in a circuit is zero. What is called algebraic sum? It might have positive sign or negative sign. So only the word algebraic sum. Sigma I is equal to 0, meaning I1 plus I2 minus I3 plus I4 minus I5 is equal to 0. Plus minus. So the word algebraic sum. Second law, otherwise known as voltage law. Product of current and resistance taken around a closed network is equal to algebraic sum of the products. Underline the word. I1 or 1 plus I2 or 2 minus I3 or 3. Algebraic sum is equal to psi 1 plus I2 minus I3. We don't know. It depends upon the circuit. Very important condition here is circuit should be closed. So sigma IR is equal to sigma into psi. Correct, Amma? Next. Wheatstone network. Wheatstone network. P by Q is equal to R by S. Ratio of resistances are equal. Here we are following Kirchhoff's first law and Kirchhoff's second law to derive this. Next is meter bridge. Meter bridge, we are calculating external resistance of a coil and resistivity of the coil we are calculating. Same formula, P by Q is equal to L1 by L2. Of course, you have to do, we have in practicals also. So definitely you can find out how to calculate. L1 by L2, P is equal to Q into L1 by L. So Q is a known resistance here. L1 is called the balancing length. L2 is a balancing length after interchanging. Basic formula. Specific resistance, how to calculate, sir? Rho is equal to R into A. In our case, P into A by L. P into pi R square by L. This L is called length of the coil which is wounded, ma. This is called balancing length. Don't confuse. You know the theory, you know the practicals also. This is the final formula for meter bridge. Next, potentiometer. Principle of potentiometer, the EMF of the cell, psi, is equal to IRL. Psi proportional to L. This is a principle. Resistance per unit length, small r. This small r is called radius. This is called R dash. We'll take it. Resistance per unit length of the wire. The principle says EMF directly proportional to the balancing length. Of course, in practicals, you are doing comparison of EMFs. E1 by E2. No, sir. Psi1 by Psi2. Okay, Psi1 by Psi2 is L1 by L. Ratio of EMFs of two cells. This is called comparison of EMF. Sir, internal resistance. There are two concepts, sir. Calculate internal resistance using voltmeter. Already we saw psi minus V by V into capital R. This is internal resistance using potentiometer. Using potentiometer. What is internal resistance formula? Same small r only. R into, of course, balancing length and all you should know. L1 minus L2 by L2. In the secondary circuit, there will be one key. When key is closed, open, balancing length is L1. When key is closed, balancing length is L2. So final formula, R into L1 minus L2 by L2 into capital R. Unit is ohms only, because this is also resistance, this is also resistance, R dash. Unit is ohms. Already we learned about Joule's law. Correct, Amma? So these are the formulas in chapter 2, current electricity for 12th standard. Thank you.